Once more, it's enough for us to simply just find the factors of the denominator. So for our denominator, y raised to 4 minus 16, its factors are the following. So its factors are y squared plus 4 times y squared minus 4. Y squared plus 4 is going to remain as it is, but for our second factor, y squared minus 4, we know it can still be factored out. So using our difference of two squares, y squared minus 4 factors out even more to give us the complete list of factors. Y squared plus 4 times y plus 2 times y minus 2. And again, our original integrand can be broken down into simpler partial fractions, which are much easier to deal with, which are much easier to integrate. So let's decompose our integrand into simpler partial fractions. We get the following. Now it's up to us to compute what is A, what is B, and what is C. For this one, we try to multiply all terms in here, all the terms on the left, and all the terms on the right side of the equal sign by y raised to 4 minus 16. When you multiply now all of these with y raised to 4 minus 16, you get the following simplified expression. So y raised to 4 minus 16 will disappear, leaving you only with y cubed. And as for the remaining parts, on the right side of the equation, you have the following. So your y squared plus 4 will cancel out the other y squared plus 4 in our factor for the denominator, and you're left with y plus 2 and y minus 2. Likewise, for our next term here, the y plus 2 on the denominator over here will cancel this out, leaving you only with y squared plus 4 and y minus 2. Lastly, the y minus 2 on the denominator right here will cancel out the y minus 2 in our factor for the y raised to 4 minus 16, and leaving you only with y squared plus 4 and y plus 2. So with that simplified expression, it's now time for us to assign values of y so that we can find the values of A, B, and C. Okay, so let's choose. The values of y can be chosen at random. It's up to you what values you choose, but it's easiest for us to just choose values of y so that certain terms in here disappear, leaving you only with one unknown value. So let's say you choose y equal to 2. If y is equal to 2 now, 2 minus 2 over here will make this entire term, the A term, disappear. Likewise, substituting 2 over here will make this entire term disappear as well, leaving us only with the C term. So let's do that. Let's have, for the first try, let's have y equals to negative 2. So with that, substituting negative 2 to our entire expression over here makes certain terms disappear. For instance, negative 2 plus 2 will become 0. So all of this will disappear. As you can see, not yet. And likewise here, in our C term, negative 2 plus 2 is also 0. Thus the entire C term also disappears, leaving us only with the B term. So with that, we now get negative 2 quantity cube is 8, and the B term gives us the following. So simplifying all of that gives you B equals to negative 1/4. Now let's assign a new value of y. Since we're done with negative 2, which makes the y plus 2 terms over here disappear. Let's now select y equals to 2. That way, itong mga y minus 2 dito, these terms will now disappear. And only the c term here, which has no y minus 2, will remain. So letting y be equal to 2, you now have the following expression. So on the a term, as we've noted, 2 minus 2 equals to 0, which leads to all of this here disappearing. Likewise, the b term over here will disappear as well, since 2 minus 2 is equal to 0, and thus leaving us with only the c term. So for the c term, we'll get 2 squared, that's 4, plus 4, and 2 plus 2 equal to 4, giving us the following. So you have 8 equals to c times 4 plus 4 times 4, or c is now equal to 1/4. So one thing you'll notice here, which I'll point out as well, is that we already got the value of b, which is negative 1/4. So it's good for us to already substitute this immediately once it is already computed. And likewise, as we've already computed the c, this value of c will now use to be able to determine the value of a. Okay, so let's now assign a new value of y. Since we've assigned negative 2 and y equals to 2 as well, so let's just choose any value of y at random. Let's say we have y equals to 0. Letting y equal to 0 now, you now get the following. So substituting the y with zeros gives you the following terms. Again, we've substituted the negative 1/4 for the b over here. And as well, we substituted the value of c equals to 1/4 here. Now with that, simplifying all of these gives us the following expression. And so a is now solved, and a is equal to 1. And so with that, with all the values of a, b, and c already computed, we are now able to compute our integral. So a equals to 1, b equals to negative 1/4, and c equals to 1/4 gives us the partial fractions of our original integrand. So the integrand breaks down or decomposes into the following. So you have dy over y squared plus 4 minus 1/4 dy over y plus 2 plus 1/4 dy over y minus 2. And from that, we can now easily integrate this one. So the integral is now equal to this.